So welcome to the West Coast section Air and Waste Management Association webinar, The Climate Crisis, Urgent Need for Adaptation and Resilience Plans for Californians. We're honored to have Dr. Ramanathan. Am I pronouncing that right, please?
It's Ramanathan.
Okay. You're much better at pronouncing it than I am, Bhaskar. It must be that native language.
Yep.
So I wanted to mention a few housekeeping things. Please put all the questions in the chat. I think it's a little bit less disruptive to do it that way. All of those questions will be monitored by both Bhaskar Shandan, West Coast Section past chair, and Simon Meharamdi. I know I pronounced your name wrong too. And Simon will be our moderator. All of you, if you haven't muted, please mute. We want to make sure that we all can hear Dr. Ramanathan present. And so now I'm pleased to give his bio. Dr. Ramanathan is the Distinguished Professor Emeritus of Climate and Sustainability of the Scripps Institute of Oceanography at UC San Diego and Cornell Climate Solution Scholar at Cornell University. He discovered the greenhouse effect of chlorofluorocarbons and other heat-trapping pollutants. His findings have led to several successful climate mitigation actions in California and worldwide. He served as a science advisor for Pope Francis's Holy See delegation to the 2015 Paris Summit. He leads UC San Diego's, University of California's Bending Curve Climate Solutions education program, which is taught at many campuses around the world. He's a recipient of the prestigious 2021 Blue Planet Prize for his work on climate science and climate solutions, and similar awards from the American Meteorological Society, the United Nations Environmental Program, State of California, among others. His other honors include elected member of the Pontifical Academy of Science, he's a council member, Royal Swedish Academy of Science, which he awards the Nobel Prizes, and the U.S. National Academy of Science. We are absolutely honored to have Dr. Ramanathan present, and I'm going to give it to him and Simon to go forward. Thank you.
Can I start now?
Yes.
Thank you very much, Bernard, for the introduction. Good morning to all of you. As you see in my title, I'm calling it climate crises instead of climate change. Just in the last 5 to 10 years, climate change has morphed into what we now recognize to be climate crises. Let me just start with climate change, give you a very brief introduction to the problem. Almost all human activities dump certain pollutant gases to the atmosphere. You all might have heard of carbon dioxide, methane, there are other pollutant gases. They cover the planet like a blanket and trap the infrared heat coming from the earth, coming from the atmosphere. And this trapping by this gaseous blanket is what's causing global warming. So that's global warming, climate change. And this blanket has been thickening year after year after year, at least for the last 100 years. And so the warming is progressively increasing. About 2015, 5-7 years ago, we crossed a major threshold in the magnitude of this warming. And that's what made the climate change into climate crises visible, at least in our data. This morphing of climate change into climate crises requires a new way of thinking. Many have figured out that many scientists and now a lot of policymakers have figured out this requires this new way of thinking, and that's what I'm going to talk to you about. So just to get started, let me start with a cosmic view how interconnected we all are and how sensitive is our climate system. This is sort of shows the solar system with its 8 planets. And astronomers call our Earth in a Goldilocks zone, or a Goldilocks planet. It's just at the perfect distance from the sun. So the Earth is about 93 million miles away. Had it been 2 million miles closer, 91 million miles, the planet would have been too hot. On the other hand, if it had been 95 million, that is 2 millions further away from the sun, it would have been too cold. The whole Earth would be Earth covered. Okay? Let me give you another example of this perfect balance by talking about something, what's happening in the planet. The Earth, the planet, the atmosphere, the glaciers, everything together reflects about 29% of the sunlight coming in. Clouds play a major role. Let's say there was less cloudiness and it was reflecting instead of 29, just 27%. The additional solar energy coming into the planet would be enough to make it too hot. So that is how perfectly balanced we are. It is this balance which we are accepting. So I'll sort of talk to you later about how long is the planet going to be a Goldilocks planet. Remember, Goldilocks likes a porridge at just the right temperature. So that's where it's called Goldilocks planet. So what's happening to this Goldilocks planet? This is the review by a United Nations group called IPCC, Intergovernmental Panel for Climate Change. It consists of about 1,000 scientists. There are no policymakers, no politicians in this, it's just scientists from around the world. They release a report of the status of the planet every 5-6 years, and this was released last fall, 2021. It shows reconstruction of the temperature of the planet after analyzing billions and billions and billions of data points. What you see, it shows for the last 2,000 years, the planet has been in a reasonably, stable climate, varying a little bit, up to about 1850. And there begins the Industrial Revolution, and the dumping of gases start, and you see a major increase in the temperature. That 1 degree crossing happened around 2015, and the warming is now unprecedented in more than 2,000 years. And if you look at the whole century warming, that's unprecedented over the last 100,000 years. There are many things, unprecedented things happening. The carbon dioxide concentration, which is one of the major pollutants coming from fossil fuels primarily, and that's its highest concentration in the last 2 million years. Remember I talked to you about blanket? The carbon dioxide blanket alone is about 1 trillion tons thick. Just imagine. You don't feel this trillion-ton weight on your head simply because it is distributed around at a point. In response to the warming, the sea level has been rising fastest in the last 2,000-3,000 years. Sea ice is retreating, and so on and so forth. Everything that's happening in the planet is unprecedented. Had that been the only issue, we at least have some time to respond. What has happened since about, I would say around 2005 to 2010, this global warming has led to new weather extremes, extreme heat, heavy rainfall, drought, fires, ocean acidifying, etc., etc. So this weather extremes connects climate change directly to human health. Number of premature deaths, illnesses, etc. I'll talk to you about this later. So I told you, we passed a major threshold in 2010. In 2018, I teamed up with my colleague, David Victor, and Professor Yang Xu at Texas A&M. He was my former PhD student. We concluded, as you would see in the graph, it's going to pass another major threshold from 1 to 1.5 degree warming. Remember, that's a 50% amplification. We said it's going to happen in 2030. That's just 8 years from now. When the United Nations scientists said it's not going to happen until 2040, 45. In the recent report, they have revised their projection, and they also conclude with us it's going to happen in 2030. That is where I predict in 8 years from now, this climate change into climate crises, it will be felt worldwide. It's no more happening to your relatives living 200 miles away, or your friends, or your city folks. Everyone would feel it. Just that's our COVID moment. In 2030, our predictions are always plus or minus 5 years. Uncertainties that could happen as soon as 2025 or as late as 2035. So now I gave you a global picture. I'm going to take you now to California. My focus today is going to be on the Californian situation. This is the drought on a 5-year average data published by the US government. And you see all the brown regions worldwide, it's happening. Of course, our Southwest, the entire California, Northwest and Southwest. Amazon, the Mediterranean region, Southern Europe, Southern Africa, Northern China, Australia, etc. So it's a worldwide issue happening. So now let me take you to California. This is a bulletin prepared by me and my colleagues in my lab, Jonathan Cole and Astrid Chu. What I'm showing you here for the Northern California, I mean, we just divided California into two halves. This is showing the northern part. Hotter summers, summer temperatures increased by 3 degrees, but now I'm using Fahrenheit. There is a second thing, which is the real killer here. We call it, scientists call it vapor pressure deficit. As the planet is warming, the air is getting drier compared to saturation. We call it pressure deficit. And that vapor pressure deficit has increased by 15%. That's a huge amount. That means potentially the evaporation of water from your skin, from your trees, from your soil, all can increase by 15%, okay? That evaporation is chronic. It's happening every second, every minute, every hour, day after day after day. And this third thing which is happening in California, particularly Northern California, the wet season is getting delayed. Our autumn precipitation, fall precipitation has decreased by more than 25%, but compensated by increase in the winter. But there is an overall delay of the rainy season by 27 days. So that increases the dryness of the soil and enhances the fire season. This is just continuing. This is a bulletin, a hotspot bulletin our lab released last year. And this drying vapor pressure deficit, delayed rainfall has worsened the fire season. If you look at the data from 1980 to 2020, it used to be a few 100,000 acres burned each year. Now it's increased to 2 million acres as of this is 2018. And of course, 2020 was a record. The record-breaking 2018 fires, the cost of that is close to 150 billion, including the direct and the indirect. Of course, the 2018 was broken by 2020. The second disaster happening is the mega-drought. This is a lot of work on this has been done by University of California scientists in Los Angeles and Merced and other places. What it shows is we created a new metric for this drought where we looked at the decrease in the precipitation and the increase in vapor pressure deficit. We combined the two things, 1-2 punch. You see in this criteria, entire California, Southwest, and parts of north of even California are having this water deficit, okay? So now I'm showing you the same in a different way. This is data we got from NASA. And it shows the drought from 2000 to 2020. You can see how progressively in the last 21st century, starting from 2015, we are slipping more and more into extreme drought, which is the red and the reddish brown exceptional drought. And you can see the extreme drought reached sky high in 2020. Almost 90% of California is suffering this, okay? So it's no surprise our Governor Newsom last year, October, declared state of emergency as far as this drought is concerned. Now let me take you to the fires. This is NASA data from satellites, and they show this from 1970s. You can see people say, oh, California is always experiencing fire. That is true. But what is not, what is new, is that those fires are getting more intense and extensive and covers vast areas, as you can see in 2010 and 2020. It's changed from blue, mild fires to completely red in 2020. How much of that is due to climate change? Remember, some of the fires would happen naturally, and I don't know how many of you know, 80% of the fires are triggered by human activity. Someone lighting a tar, someone doing barbecuing. So the question is, many happen to think, oh, it's just natural or man-made, but in a different context. No, this data shows how much of those wildfires is due to climate change. So you see 1985, it's minimal. Gradually, the role of climate change is increasing and increasing. Now it's almost half. So how does climate change contribute to that? Because of the vapor pressure deficit, it's just drying the soil, it's drying the tree trunks, it's drying the leaves. It's an evaporation, and then the rainfall delay, okay? In fact, this week there was a major study by University of California scientists who said the drought we are experiencing 20 and 21 is unprecedented compared to the last 1,200 years, okay? It's a once in thousand year event we are causing. And the cost of these fires are also escalating. It used to be around a few $1 billion in the 2010 to 15, and since 2016, it's increased tenfold. The cost is also huge. I want to show you the 2020 broke all the records there is in terms of fires. This is from the California government data, CAL FIRE data. There were a number of casualties. Over thousands of structures were destroyed, and it consumed over 4.2 million acres of forest, the fires. I just want to give you a perspective. What does 4.4 million acres mean? The total land area of California is 100 million acres. So that's almost 4% of California was burning 2020. So we had a double suffering, COVID and the fire crises. And the forested area of California is supposed to be 33 million acres. So buying 4 million acres is 12% just in 1 year. 12% of a forest. Hundreds of thousands had to flee homes, and millions were exposed to dangerous air pollution. I want to report to you, so far I talked about ecosystem. Let's talk about people. This was a unique study done by Dr. Jyoti Mishra. She's a neuroscientist at the University of California, San Diego. She also had a laboratory, director of a laboratory looking at translational research. What she and her colleagues found of the about 725 sample, 3 major mental diseases increased by nearly more than 50% or more. So the light gray is the sample of people not exposed, and the hatched one is directly exposed. If you compare the symptom severity of PTSD, that's about 60% increase. The second criteria she looked at is major depressive disorder. That increased by 50%, and general anxiety disorder also increased by 40 to 50%. So there is a huge public health cost to all the suffering that's happening. So we don't have to feel too bad. It's, California is suffering, but we are not alone. Look at the whole, what's called, the Mediterranean region, both north in southern Europe and south across Africa, a lot of parts of China, Australia, Amazon, etc. So it's kind of a worldwide phenomenon, what we are experiencing here. So given all this bad news, the question we can ask, can it get any worse? Unfortunately, it can, due to a statistical, dynamical phenomenon called fat tails. Okay, so let me just give you a brief review to that. This is a paper we published 4 years ago. It shows the probability distribution of what can happen if we do all the mitigation steps, which people are talking, making the planet carbon neutral. It's what's called a bell-shaped curve, but a bell-shaped curve. You see how in the left-hand side, on the lower warming, it ends rapidly. On the right-hand side, it doesn't end. So that's the fat tail. So most of us talk about if we cut all the carbon pollution, this and that, we can limit the warming to less than 2 degrees. The bottom is 2 degrees, the top is probability. So around the peak, that's 50% probability. But if you want to see what could happen, if you look at the 5% probability, that's a 1 in 20 odds. The warming could be as large as 3 degrees. Rarely people talk about that. When they say 2 degrees, they're talking about 50% probability. So you can say, 5% probability, that's not going to happen, but that's 1 into 20 odds. Okay? So these are called high impact, low probability events. What happened in 2020 fire is one such thing. A low probability event, 1 in 2,000 years, but it happened. Okay? So the question is, what do we prepare for? For the 50% probability, then we say, we can limit the warming to 2. Or we say, no, it could happen 3 degrees. Should we prepare for that? That's one of the key questions. So on the fat tails, this is the simulation by a group at Princeton University and NASA and NOAA. There is a 5% probability by year 2050. This is what we would see. Droughts, major parts of the US, including the plains, central plains, Amazon, entire Amazon, the entire Mediterranean. So our Goldilocks planet could be shrinking, okay, in terms of habitability, somewhere between 2050 to 2100, if we don't do anything about climate change. So the last thing I want to give you, why all of this is happening, is the domino effect. Then I want to move on to the solutions part of this, okay? So let's see what's happening in California. I got 2 domino effects. First is the warming causes the vapor pressure deficit, not enough moisture in the surface layer, more evaporation, drying. The drying leads to forest fires. When you lose the forest and the trees, the water runs off and leading to drought downstream, causing water insecurity for agricultural people. And look at the other domino on the left-hand side. When you warm your hills and the air above the hills, the snow melts early in the season, and more of the precipitation falls as rain and not as snow. It's the snow which can store the moisture, so you have more runoff, forest drying, forest fires, etc. So it's just not one thing that's causing 4 million acres burning. It's this domino effect happening on different parts of it. Okay. So enough of the bad news. Now let's talk about how can we address this? How can we minimize this? And how can we solve some of the problems? So the resilient nature, resilient humanity is a project I am now leading for the Vatican, the Pontifical Academy of Sciences. We are starting a major effort to look into this issue. How are you going to give resilience to people? And this thought even arises because some of the climate change is happening and some are unavoidable, okay? So the resilience normally gives you that thing about adapting. No, resilience is a combination of mitigation to reduce the risks, and then it's adaptation, and then the society transforming so that it can bounce back. So by definition, resilience is capacity to prepare, plan for, absorb the shocks, such as fires and floods, recover from them, and adapt to climate risks. Who is doing the adapting? It starts all the way from an individual to your community, to your city, a state, or a nation. And the capacity for resilience, of course, applies to natural systems. They have been resilient over thousands to hundreds of thousands of years. So let's take one more look at it. So I'm addressing resilience. What is it? First, prepare for climate risks. Second, bounce back from impacts from climate change. And that's what, remember, we have a national plan, build back better. Third, if none of this is possible, if you can't reduce the climate risk, and if you can't bounce back from your current adaptation, a whole societal transformation has to take place for sustainable living. And the climate risks are twofold. One is acute events, weather extremes, floods, fires, and to chronic events, sea level rise, ocean acidification, mass migration of displaced society, and loss of biodiversity. Losing forests is one loss of biodiversity, okay? So when you talk about risk, the risk is a product of the vulnerability and threat. The threat is a heat wave coming out next 2-3 days, or massive flooding, okay? And the vulnerability is key here, because if the sea level is rising, I'm living on a hilltop, I'm not that vulnerable. My neighbors people living close to coast, of course, highly vulnerable. Same thing, you get vulnerability is people dependent, ecosystem dependent, and where you're living. Sensitivity, okay, vulnerability is a product of three things. First is sensitivity. For example, when you have fires and the smoke is traveling around, I have asthma, I'm highly sensitive. If you don't have asthma or pulmonary issues, maybe you are not that sensitive. The second is exposure. How many are exposed? So that's where the number of people come in. And the third is adaptive capacity. Your ability to adapt depends on your culture, your economic stature, your education, etc., etc. Okay? So in terms of managing the risk, there are three categories. One is risk mitigation, that is emission reduction and carbon extraction. I'll talk about that. Risk transfer. You transfer your risk by taking insurance. This is going to be a major issue for us. I'll mention that. And risk acceptance. For example, we live in California, with earthquakes, because it's not a highly probable event, very, very low probability. So we accept it. And the key thing about resilience we can't forget is inequality. And I was shocked to see the statistics in the California, one of the NGOs, 22% of Californians live in poverty. Our population is 40 million, so 8 million are going to be highly vulnerable to all this weather catastrophes. Okay, so we have to keep that in mind. So I see this resilient nature, resilient humanity, resilience as a function of three pillars. Mitigation, that is basically reducing the risks. adaptation, and transformation. So let me talk about mitigation first. There are three levers we have to pull to bend that warming curve. First, we can reduce the warming quickly by bringing down emissions of what some call as superpollutants. These are gases such as methane, soot, it's a particle which comes out of diesel, the black stuff, and gases like fluorocarbons. These are called superpollutants because per ton of emission, they're anywhere from 25 to 2,000 times more potent than carbon dioxide. And their lifetime is short, weeks to years, so we can bring them quickly. The second lever, of course, we need to pull is what most people talk about, cutting down our carbon dioxide emissions to zero. So this is called carbon neutrality. To keep the planetary warming under 2, almost all of us agree we have to reach zero emission in 30 years. But unfortunately, I used to think these two were enough until about 2015. Now I know we've gone too long into this and the dangers are imminent and the blanket has become too thick. Remember I said it's 1 trillion tons thick and we are adding 40 billion tons every year. So we have to take out almost 500 billion tons of carbon dioxide out of the air, okay? Hopefully by 2050. So that's why, that's going to be the gigantic problem. Just recently, today I heard from New York Times, Elon Musk has offered a $100 million prize for those who are going to come up with scalable solutions. Now, what's California doing in terms of this mitigation? Doing amazing things. They have an action to cut the superpollutants, and the state's carbon-free energy goals are aligned with limiting warming below 2 degrees. On the bar chart I show, California is already using 34% renewable and plan to go to 100% carbon-free energy goal by 2045. That's just fantastic. What's missing in California's plans is carbon extraction. I hope somebody from the government is listening to the talk. We need to draw 150 million tons, just California alone, by 2032. It's not 150 million per year. It's 150 million tons total. That is a typo in my slide. So let's go back to, I talked about mitigation. Now I'm going to talk about adaptation, okay? In terms of resilience and adaptation, that contains of adaptation, bouncing back, and societal transformation. It's a multi-dimensional problem. The ecosystem is involved, social system is involved, economic systems, urban systems, and human health. My biggest concern focuses on people, human health. Of course, ecosystem health is just as important. This just shows from our government website, what do California forests do for us? It provides a water supply. It provides mitigation because the trees draw down the CO2. And of course, it provides habitat for wildlife and for human recreation. So it's a huge resource, which is what making living in California. And we somehow have to do everything we can to prevent the further destruction of our forest to fires. Second adaptation, I'm very happy California has released this adaptation planning guide in 2020. Its report shows it's fully aware and cognizant of the multi-dimensions of the adaptation problem. Okay? But let me tell you what's missing, what I'd like to see included in our California plan. We need to recognize every decade will be worse than the previous decade, at least for the next 30 years. So there is no norm. We are just going from one abnormal situation to the next every year, every decade. I don't see the adaptation plans cognizant of that. Second, agriculture consumes somewhere between 70 to 80% of the total water consumption. With worsening drought, is that even sustainable? Or if we want to continue with our current food product, we are a legendary producer of food for the whole of the nation. And I hope we can maintain that. But does that mean we need to pump water from out of state? Okay. Third, if 40% of the forest area is burned or partially burned, I worry if those, living in the so-called middle class, if they're going to be able to get fire insurance. And I don't see the recognition of that. How far has insurance? Maybe they would withdraw. The last issue is millions are going to be displaced in other parts, in North America, in Central America, Mexico, and Central America. Is mass migration going to be an issue for us? I would like to see a discussion and consideration of this. So I want to conclude with first a recommendation from my group. The first thing I want to mention is there is still time. The situation looks almost hopeless, but it's rushing, but there is still time. What I would recommend is that on the resilience issue, the state prepare for a further worsening of the extremes by at least 50%. This is bringing in the fat tails. We need to develop a 10-year climate resilience plan. When there's no baseline, when there's no norm, we are just getting progressively worse. We need to protect all the vulnerable people. That if the state has 22% living in poverty, we have to protect them and others from heat waves, wildfires, and smoke pollution. We need to mount a massive effort to pay attention to the public health and mental health effects, okay? Giving resilience. Experts tell me it's possible. And I think our agriculture industry has to shift away from thirsty crops and more go for sustainable agriculture. And remember, I talked about societal transformation. We need a statewide climate education for all program. Now, I'm happy to say University of California has started an initiative for climate education of all undergraduates, and it's collaborating with California State University for K-12. But we need a massive initiative to educate all the private sector, educate all the NGOs, and educate our public, because it's going to require massive expenditure to build resilience. And of course, we have to bend the warming curve. I list 5 things here: fossil-free power generation by 2030. California has 2045, which is I'm very happy with, but it can be accelerated. We have to bend the methane emissions curve by 2025 by not throwing food into trash cans, recovering the methane, etc. We need carbon-free, soot-free transportation by 2035. I led a study for CARB in which we showed diesel, soot from diesel is about 2,000 times more potent than carbon dioxide. Fourth, we have to retrain and relocate displaced fossil fuel workers because we are big on producing natural gas. We cannot just, we all benefited from them. So we have to find ways to relocate. Of course, not many in the nation are following this, so California should lead and inspire and followers in other states in the nation. I'm super happy to say our San Diego Congressman, Scott Peters, has led a bipartisan bill, both in the Congress and in the Senate. Senator Chris Coons and Lisa Murkowski, Republican, they put forward a National Climate Adaptation and Resilience Strategy Act of 2022. He just informed me about this yesterday, and I I'm super delighted. This is exactly what we should be doing. So let me conclude with my last slide. This question was in one of the website of our state NGOs, Cal Matters and others. Whatever happened to the California dream? There was an article in New York Times about this. And what I firmly believe, there is about 15 years to adapt, bounce back, transform, and keep the California dream alive. But it's not going to happen without massive effort, bottom up. And that is one of the reasons I agreed to participate in this webinar. We need street-wise, house-wise, community-wise dialogue on how to make California resilient. Thank you for inviting me.
Thank you very much, Dr. Ramanathan, for the very informative, eye-opening presentation, laying out the challenges ahead of us and also some path forward. We are having a lot of questions coming up in the Q&A or in the chat section, so I will start with the first one. So Henry is asking, do you have any climate adaptation recommendations for chronic events like sea level rise?
That's an important question. We need to think about two separate issues here. Short term is what's going to happen to us next 5-10 years. And the longer term, what's going to happen between 30 to 50-year time frame. So the sea level falls on the longer term. And I come from Scripps Institution of Oceanography. We have a major adaptation center on these issues. But my focus has been on the shorter term adaptation and resilience. Okay? The sea level issue is a huge issue. Has massive implications. Majority of Americans live around the coast, so I think of it as a national issue. And so far, I have not seen any specific recommendations of how to prepare for it. I want to share with you one thing going on. So far, I would say 80 to 90% of the attention has been on mitigation. We thought we could cut down the emissions in time to limit sea level rise, this and that. Now we know that's not going to happen. We are going to level the warming. I'm very optimistic we're going to keep the warming under 2 degrees. But because of this fat tail, sea level rise could be a few meters. That's about 6 to 10 feet. So we need to develop plans for that. They're not happening with the urgency of the attention it deserves.
Thank you very much. I move to the next question. Jia Chen, she has a question and she would like to actually ask the question herself. So I'm going to try to unmute her. Or Bhaskar, maybe.
Yeah.
Oh, there you go. Go ahead, Jia Chen.
Yeah, thank you. So thank you for your wonderful presentation. I really love how you laid out the different strategies from reducing super pollutants with very high global warming potential to CO2 and moving forward. So my question is regarding the soot reduction strategy, because soot is often co-emitted with other aerosols like sulfate that can actually reflect sunlight and reduce global warming. So I was wondering what would be your consideration regarding now that many developing countries are reducing aerosol emissions, will that be a chance that actually lead to global warming because of the reduction of sulfate aerosols, or like how certain in academia that we are right now regarding the related forcing of aerosols in general? Thank you.
Excellent question. first of all, if you just focus on California, our major soot, we don't produce coal, we don't produce soot emitting energy sources, but our major source of is diesel. So if you target diesel emission, soot is the dominant source of climate change. It produces NOx and nitrates, but not sulfates. Because the sulfur emission has been cut because we use low sulfur diesel.
Right.
And when we switch from gasoline vehicles to electric vehicles, which California is going to have a big time, that problem will automatically solve. But let's talk about the national and the global issue. Cutting down pollution from coal, of course, you cut the CO2. That's a huge reduction. Of course, the coal produces sulfur, and sulfur produces mirror-like particles, which cool the climate. So there is going to be some, negative in terms of the warming. But the thing you have to remember, that's something we have to put up with, simply because the particulates kill 8 million people every year. In America, it kills 250,000. So that's why I'm pushing for, just don't look at it as a climate problem. Think about human welfare, public health. You have to make an action which is good for public health and the system and climate change. Then there's no doubt you have to get rid of coal, even though it produces this mirror-like particles. And offset the warming that come from reducing this sulfur and other particles from fossil fuel, you cut super pollutants. So that's why you need this 3-lever strategy. And thank you.
Yeah, I agree with you. Thank you so much.
This is Krishna here. I wanted to ask a question. I was typing, but somehow I'm not getting through there. I have a question. It seems that unaccounted methane emissions may contribute significantly higher GHG emission than previously thought. How do we account and reduce these emissions? Because this is going to be a significant emission actually coming from the fossil fuel production places.
No, you're absolutely right. There was a major study which came out a couple of weeks ago showing hundreds of millions of leakages. To me, cutting down methane emission from fossil fuels is an easier target because most of that comes from leakage of pipes in the transmission. For example, if you have gas in your home, some of the methane, natural gas is basically methane, and it escapes so it's a question of maintaining the pipes. Second, a lot of the natural gas is flared at the production site, and that has to be, that's ridiculous to do that. So that has to be avoided. But the second source of methane, I tell you, is an easy target, is that when you throw your food and other organic waste like grass into the landfill, it produces methane and the methane leaks. So I think California is getting there. We have to ban throwing food in the garbage. It has to be processed into fertilizers and put biodigesters and create biofuels. So methane has to be a major target, and I've been pushing for this for at least last 15 years, and I'm happy to say under Governor Jerry Brown, they passed a law to cut short-lived climate pollutants. Methane was one of them. Good question.
Thank you.
Thank you. I will move to the next question in our chat. Sarah Head is asking, pumping water from other states does not sound realistic. They are in drought conditions as well. What are your thoughts about desal plants?
Yeah, thank you for asking that question. when you say pumping water is not feasible, we are pushing for major pipeline to take shale oil from Canada all the way into US. So why can't we use those pipes to bring water? So what's happening in terms of precipitation is it is moving northwards in the Northern Hemisphere, okay? So I fully expect more rain to be falling on Canada, British Columbia, and even our northern state, Washington State. And we should be thinking that's one of the resilience plan where we come back better, bounce back. It's a major water system. Remember, a lot of our water in Southern California comes from Colorado River. So water comes long distances, flows. It requires energy. The desalination issue, I tell you why I'm not pushing it. I'm not against it, but I'm not advancing it because of the issues. The salt in the ocean, salinity it's called, drives ocean circulation. So I worry about we taking water from the ocean. What are we going to do with the salt, which is left behind? And the second thing which worries me about that is the enormous power used. So if you're going to use all the power, renewable power, for getting water, we are going to be dumping more greenhouse gases. So it's a trade-off. So that issue has to be, there are a lot of pros and cons. But then, if you go to places like Israel, massive desalination is being done. But I worry about that there are a number of other issues which has to be considered. But certainly, I agree with your question. Experts in California have to weigh all these pros and cons.
Yeah, thank you. I think about the, we used to pump water from Northern California, and in the process, we kind of dried up, Mono Lake and other areas. So it just doesn't seem like pumping water from long distances is a really good long-term solution either, just because it's creates so many issues of they're going to eventually run out of water too. So, but thank you for your answer. I think that was kind of what I was saying. You really need to look at all the options, not just that solution.
Thank you, Sarah, and thank you, Dr. Ramanathan. Our next question is from Alice Truffle. Alice is asking, what do you see as the most crucial type of bills that can be passed in California legislature?
It's tough for me to say. I'm not a politician nor a policymaker. My background is in climate science. But what I would like to see, I listed those items in my talk. I want this, I would like this adaptation plan. It's a great start, but it doesn't specify what they're adapting to. That's my fundamental problem. Are they adapting to 1 degree warming, 1.5, 2 degrees? It's not clear. So they have to have a 10-year plan, but implemented year after year. So in terms of the bills, I'll tell you what is obvious things to do is to cut down our risks, okay? The risks, like I said, cut down, methane emissions by just banning throwing food into your garbage cans, okay? The simple things which improve society's well-being. On the adaptation issue, on resilience issue, like I said, again, it has to be priorities. I would like to see a discussion of if the fires become 50%, 100% worse, what's going to happen to our insurance industry? How are we going to insure our people's homes? I'd like to see that discussion. Okay. And fire prevention and making your homes fireproof is another massive discussion I'd like to see. And the fourth, I would put it high on the priority. If California is going to slip into further and further into mega droughts, there is a study which is showing by 2050, there's an 80% probability. Right now, the mega drought probability is 10, 20%. It'll go fourfold. So they need to work with the agriculture industry. Current agriculture consumes 75 to 80%. And that, I don't see how that is going to be sustainable with the climate worsening. So I'd like to see a major discussion of that and come with a plan that we don't grow the crop thirsty, water thirsty crops, but still maintain our superb position in agriculture, but shifting to other crops. Okay, I clearly see independent farmers going downhill pretty fast. I don't think the big ones can survive. They can probably dig deeper and deeper, into the land. So that's my biggest concern, the agriculture with consuming 80% of the water. And there are many I can go down the list, but yeah.
Thank you, Dr. Ramanathan. We are getting close to 1, so in the interest of time, I will turn it over to Bhaskar, but we have a few more questions in the chat box. Maybe at a later opportunity, we can ask those questions from you. Thank you.
Thanks, Simon. Yeah, we can maybe email the questions to Dr. Ramanathan, and it's in the chat box. We'll take a printout of the chat box. Thank you, Dr. Ramanathan. Really appreciate your presentation. It's very informative. We had a pretty healthy audience. There were also many people and a lot of questions. We couldn't get through it, and we apologize for that. But thank you all for attending this webinar. We have many more webinars coming up. If you go on our website, you will be able to see every month we are trying to have one webinar. If you are not on our mailing list, join our mailing list so we can send you all the information. The presentation of Dr. Ramanathan is already on our website, and we are recording this presentation, and that will also be available on our website. Please let me or Simon know if you have any other questions. And thank you again. Hope to see you again next month at our next webinar. Thank you all.